So in this video, we're going to talk about atomic mass. So remember, atomic mass is the number below the symbol on the periodic table. So this is our atomic number, it's the number of protons, our symbol, and this is our atomic mass. Now remember, we said that our atomic mass was the number of neutrons plus the number of protons. But now we're saying, okay, well, why is this number with a decimal place? If it's protons and neutrons, then shouldn't it be a whole number? So let's talk about why it's not a whole number. So one thing that we need to remember when we're talking about this is that not all atoms of an element have the same mass. So I'm going to have different atoms of chlorine, but they're not going to have the same mass. So you might say, well, why, if it's all chlorine, do they not have the same mass? Remember, we talked about these. These were our isotopes. Okay? They've got a different number of neutrons, and so that means they have different masses. So if I take all my isotopes and I add up their masses and try to find like an average mass, it's not going to be a whole number because they don't have the same mass. So what ends up happening is that my mass number is going to be an average mass. So that's going to be my atomic mass. Is going to be an average mass. So we have to take into account the different isotopes, but not only do we just say, okay, well, if I have 3 isotopes, I just add up their masses and divide by 3. We don't want to do that because you don't have all 3 isotopes in the same proportions. Remember, there's difference in abundance. Usually one isotope is really abundant, and that's the main isotope that you're going to experience, and then you've got maybe 2 to 3 other ones that are prevalent but not as much. So we have to take into account the isotope's mass, but mainly its abundance. So when we talk about taking an average mass, it's like a weighted average mass. So kind of think about when we do your GPA. You've got quizzes, you've got tests, you've got all these different things that add up to your course grade for a class. You don't just average them all together. They're all different percents. Your tests are worth different percents than your quizzes. So you have to take the percentage that those are worth and multiply them by how much you made, what your average is on your quizzes, on your tests. So it's a weighted average, okay? So let's write out our formula for this. So my atomic mass is going to be equal to, this is a capital sigma. It's a summation. So I'm going to add things together. I'm going to add up the fractional abundance of my isotope. So that just means instead of like 70%, it would be 0.70. So change the percentage to a decimal. So the decimal of my isotope's abundance times the mass of my isotope. So the mass times the abundance, and I do this multiplication, and then I add it together for every single isotope I have. So that's what this means. So if I have 3 isotopes, I do this for each isotope and then add those numbers together. All right, so let's do an example. Says if copper is 69.17% copper 63 with a mass of 62.9396 AMUs, and the rest is copper 65 with a mass of 64.9278 AMUs. Find copper's atomic mass. So what am I looking for? I'm looking for the atomic mass of copper, which is my Cu. So that's what I'm looking for. I'm looking for the atomic mass of copper. So then I want to say, well, what did they give me in the problem? So they told me that I have copper 63, and this guy is in 69.17% abundance, and he has a mass of 62.9396 AMUs. So I know the percentage of this isotope, and I know his mass. Okay. What else do I know? I know that the rest of my copper is copper 65. So there's only 2 isotopes. So the other one is copper 65. What do I know about that? I know its mass. They don't don't tell me the percent abundance. So that's all my numbers. I have my two isotopes, my percentage of one, and my AMUs of the other. So I want the atomic mass. So let's go back to my atomic mass formula. So we said atomic mass is equal to the summation of the fractional abundance of my isotope times the mass of my isotope. So to be able to solve this, I have to know the percentage of my isotope and the mass. So I have two isotopes. So for this one, I know the percentage, which I could change to the fractional abundance by moving the decimal over twice, so divide by 100. So if I divide this by 100, I get 0.6917 is the fractional abundance, and I know the mass. Now this one I don't know the fractional abundance, but so let's think about this. My copper has two isotopes, this guy and this guy. So those two isotopes, their fractional abundance should add up to what? To 100. So if this one is 69.17, then this has to be the rest. So all I need to do is I say this has got to be 100 minus 69.17. And so that gives me 30.83%. Change it to fractional abundance. I move the decimal over twice and it gives me 0.3083. So now I have the fractional abundances and the masses of both. So now I can fill it in. So what this says is for the atomic mass, I take the fractional abundance of 1 and times it by his mass. Then I take the fractional abundance of the other one, times it by his mass. And that's what this says. The abundance times the mass. The abundance times the mass. This says add them together. Okay? So multiply them and then add them together. And so that means that when you do the math, my atomic mass ends up being 63.55 AMUs. Now, we can kind of think about, does this make sense? So my two isotopes are 63 and 65. So my mass has to be between 63 and 65. Okay? So if your number is not between 63 and 65, then you're really wrong. Okay? Also, let's think, which one is more abundant? This guy's 69%, he's 30. So he's more abundant. So my number is going to lean closer to 63 than 65. So I need to have a number that's going to be closer to 63% than to 65. And my number is 63.55. Okay? So now I have my atomic mass. If I had 3 isotopes, you would just do this 3 times. Add up 3 different fractional abundances times their masses of their isotope. So that's how we get this number to be a decimal versus a whole number. Okay? So on our next lecture, we're going to talk about the most important part of this entire chapter. And this concept is going to be something that you're going to use the entire year of chemistry. Not just this chapter, but every single chapter from here on out, we're going to talk about something called the mole. So this is a very important topic. So you want to make sure that you pay attention to the last couple of slides in this chapter.